How many critical points does this function have? It has one critical point. Does that depend at all on A, B, or C? So the number of critical points does not depend on A, B, or C, but the location does. So there's one critical point, and no matter what I do to drag around, no matter what I do, there's still one critical point, right? It's just that the critical point moves. So there's one. This doesn't depend on A, B, or C. But then where the critical points are does. Well, maybe it depends on all of these parameters. Let's see. Yeah, there's the critical points are moving with A, the critical points are moving, the critical point is moving with A, the critical point is moving with B, the critical point is moving with C. Although the X value isn't changing when I change C, and that's kind of interesting. Only the Y value. Where are the critical points of P of X equals ax squared plus bx plus c? Well, we have to solve where P prime of X is equal to 0. And you told me correctly that P prime is 2ax plus b. So we need to solve 2ax plus b equals 0. X equals negative b over 2a. So we saw that. We saw that the critical point moved when b moved, and the critical point moved when a moved. And this is why, because if you solve it out in terms of these parameters, the x value of the critical point depends on these numbers. So finally, how many inflection points does this have? Or is there anywhere you see the concavity change? I don't see any concavity changes. To you, it's concave up the whole way. No inflection points. The function is concave up the whole way. And that doesn't change regardless. It doesn't depend on A, B, or C at all. There's always either concave up, although it could become concave down. If I take this value of A and make it negative, it becomes concave down. So that's something we can record as well. There are no inflection points. Concavity is always the same. But whether the curve is concave up or down depends on what's P double prime of X? It's the derivative of 2ax plus b. It's 2a. Yep. Notice this will not have a sign change. This is just a constant value. And so that explains why we didn't see the concavity change. It was either always up, the second derivative was positive when a was greater than 0, and negative when a was less than 0, but it never changed because the second derivative never changed signs.